Hi everyone, welcome to the video. In this video, we are going to solve Geekina Hate once. In this question, forget what is written in the question set. You need to return nth non-negative integer with at most k set bits. Remember that nth non-negative integer with k set bits, at most k set bits. So example one, you have 5 and as 1 as n and k as 5, k as 1. Okay, so now you have to return fifth non-negative number which has at most one set bit. So these are the numbers, okay, which are having at most one set bits. At most means you can be less than that also. Okay, most you can have k, but you can have less than k also. So and they are arranged in an ascending order. You need to return the nth number which is 5. The fifth number is 8. 8. Fifth number is 8. There is a maximum number which is having at most one set bit. Similarly, for example 2, you have n as 6 and k as 2. Sixth largest non-negative number which is having at most two set bits. Okay, so here example you get 5 which is having two set bits at most. So this is a hard question, and this may look very cumbersome in order to begin with, but we will solve this question in very small chunks. Okay, so as we have learned in our junior classes that permutation and combination. So I will be using combination first of all, combination of NCR. Okay, what it will return? It will return factorial factorial n. So it is factorial n upon factorial r into factorial n minus r. Factorial r into factorial n minus r. Cool. But let me close it. Let me include this factorial so that we do not have to solve the question. So from map import factorial, and we will also include log 2 because we will need in our question. You can see these are just log 2. In order to find the set bits, we are using log 2, log base 2. Okay, so this will help us find the combination. Okay, NCR is n factorial upon r factorial into n minus r factorial. Okay, now if n is greater or equal to r, it's not ending here. If n is greater than or equal to r, then we have to return this one, else we will return 0. Okay, so if n is greater than or equal to r, it calculates using the formula. If not, it will, if n is less than r, then it will return 0. That is what we have learned in our class 11th or 12th. Okay. Now, next we will find count set bits, count of set bits. We take two integers. How they are. See, here I'm using just arguments. You may be wondering, how am I finding this? But as we go deep in the equation, you will know. I will be using binary search also because see in the time complexity you have k log n, k log n. Okay, k log n is a time complexity. So log n, where there is log n, it should ring a bell that you should use binary search in order to get the log n complexity. That is what we will use. I will go through. Okay, so this count set will have few base cases. Okay, if k is 0, if k is 0, this means we are looking for number with 0 set bits. So only number that satisfies this condition is the number 1, because okay, it's 0 itself. Okay, any number which has 0 set bits is the number 0 itself. After that you can take any number, let's say 1 2 3 4, nth number, infinity. It will have set bits, it will have set bits, but any number which is having 0 set bits is a 0 itself. Thus we are returning count, we return 1, so there are one such number. Now if x equal to 1, this means if x is 0, this means there are no more set bit left to check. If the x is the integer on which we are checking, so if that number itself is 0, it means we have no such set bits remaining. You may be wondering why it is 0, because further we will do some calculations in this function itself, in count set function itself, that will reduce the number. Okay, in that case it will be 0. There are no set bits remaining. Now I will create a variable h which will store the highest set bit, highest set bit, highest set bit in x. Means this will calculate the position of the highest set bit. Okay, position of the leftmost one. Highest set bit is what? Leftmost one in this binary representation of a number. Okay, so log base 2 of x will give us the binary representation, and we will store the what? Rounding, typecasting it to integer, will store its leftmost set bit, which is the highest set bit. Now there is a condition. There is a condition. If this highest set bit is less than k minus 1, if this highest set bit is less than k minus 1, this will mean there are not enough set bits. There are not any enough set bits, okay, left in this integer x to satisfy the condition. Hence, it will return 0, because there are not enough set bits to satisfy the condition. Okay, you cannot solve further. And at the end, it will recursively call combination combination which we defined earlier with this highest set bit and k, with this highest set bit and k. Okay, why? Because this will calculate the number of combinations of choosing k set bits from h bits, k set bits from h bits. Okay, that is why combination h comma k. Okay, this will represent the number of integers where the highest set bit is included in the set of k set bits. This will include, I will repeat, this will represent number of integers where the highest set bit is included. Okay, and apart from that, we will just add this function itself, count set, with two condition. We will do XOR operation edge. Okay, and a minus 1. What we are doing over here? What we are doing over here? We are flipping the highest set bit. We are flipping the highest set bit to 0. Highest set bit in this integer x to 0. We flipped it. Okay, and also removed one set bit from this number. This will remove the, because after flipping, let's say there are 4 set bits in this integer x. Flipping the highest set bits, the leftmost one, will reduce the number of set bit by 1. Okay, because we flipped it to 0. Earlier there were 4 set bits, now we will have only 3 set bits. Cool. Now k minus 1, because this will decrease the target count of set bits by 1. Okay, by count of 1. This is why we are checking if k is equals to 0. Okay, if there's nothing left to check. Okay, after that we'll just create a function that will count all the, all such possibilities. So this total xk will check summation of count. It will get the summation of count, return sum count set. Let me write it, then I will just tell you what it does. So as you can see, we are using list comprehension. Okay, now what it does, so this uses a list comprehension in order to generate a list of counts of set bits of x, list of count of set bits of x for each possible count from 0 to k. 0 to k we are checking, so we are k plus 1, so it will go up to k. Okay, it will go up to k, and it will check count of set bits from for x. Okay, cool. Now we have calculated this also. At the end, we are just moved back to our main function. We are moved back to our main function. Here we will define two integers. We will define two integers, low and high. That is how, this is where we will use binary search. Low will be having 0, and high will be having very big value, because see, n can be n can be equal to 10 raised to power 9. So we'll be giving any value greater than this 10 raised to power 9, but it should be much greater than this. Okay, so let's say I'll give 10 raised to power 15. I'll give 10 raised to power 15, a very big number, and bigger than this, the maximum range. Okay, now let's get back to the question. Okay, then we will apply a binary search. We'll apply a binary search. Okay, now while low less than high. Okay, while low less than high. So this includes low, but does not include high. It should be less than high, man. Let's be high, less than high. Okay, and for every iteration, we'll calculate the mid as you do in any binary search equation. So low plus high minus low by 2. Okay, now if total mid comma k is greater than equal to n, what it does, what it does, it checks if the count of numbers less than or equal to mid. Okay, if the count of numbers less than or equal to mid with at most k non-zero digits set bits, okay, which we achieved using this total function, mind that. Okay, if that count of set bits is greater than or equal to n, if this is the case, it will update high to mid. It will update high to mid. Okay, because inclusive of mid, it will include the mid because mid might be our answer. Mid might be our answer. Okay. Otherwise, if that's not the case, if it is still less than that, then it will move ahead mid low with right side of the mid. Okay, move low to the right side of the mid. Okay, and at the end we'll low return low. Why not mid? Because once the binary search is complete, low will become same as high. Low will become same as high. It will return it. So this function returns the value of low, which represents the nth number. Remember, nth number having at most k set bits. So low will become high, and it will store the value of, it will have the value of nth number, highest number, nth number, which is having the value of what, having k set bits, at most k set bits. Let us submit it and hope everything goes well. We have taken care of a lot of things. Yeah, it does the job. Yeah, it did the job pretty solid. It took very less time. And it did the job pretty solid. So I hope you enjoyed it. You have learned a very effective method of solving a very hard question. So I hope you had enjoyed it, and thank you. Have a nice day.